Dear colleagues, welcome. Thank you for joining in. We'll be speaking about the SAST and how the system helps us to find with vulnerability. I am from the PLS studio. My name is Sergey, and we are building the code static analyzer for the C++, C Sharp, and Java languages. We have been doing this for about 10 years. We've been writing different articles about the checking open source projects and sell and promote our product. Now, why are we here and what am I going to speak about? Lately, we can see that there are more and more software. There are a lot of different problems. One of the main topics is that the companies which are developing software, they're usually working with the code, they're testing the code in one way or another. They always have to rake their brains about what should they do with the increasing volumes of code because old methods aren't working anymore, which would enable us to keep the code under control. What do I mean by that? To ensure the quality and the safety of the code and to make sure that the code is reliable, would be well functioning, and there'll be less glitches and other problems. Now, people are used to high quality of the code. People are used to the fact that the code is of high quality. I doubt that you'll issue of any commercial products which will be malfunctioning, but there are other problems. One of them is code security. And lately, we hear a lot of conversations about the safety and security, about the software security, all kind of hackers attacks. So we have a lot of safety and security requirements for the code. So this is the topic of my presentation, how to make a code safer. And one example of the increasing volumes of the code with time. I could have taken a different projects with any story of several years. We're speaking about the tens and thousand times of more code uh, and and the code of several millions lines, and the team has to work with this code, maybe not every day, but from time to time. It's a legacy, and you have to go back to the legacy code anyway, and it's quite complex. And people do not know what to do with these millions of lines of code if you are facing the challenge of to look something into this code or to refactor it or to make it safer. Usually it takes using different tools and instruments, different technologies. And basically, as for the increase in mistakes in the code, this is the main problem. The errors in code are increasing. The bigger is the code, and the more examples we have in it. There are no software without mistakes, without errors, but there is some kind of different research based on which we can understand that the more or the bigger your program is, the more errors you have it, but it's not a linear dependency. The growth is happening more, and if you look at this graph on the x-axis, you can see 1,000 lines of code, and by the y-line, you can see the numbers of mistakes per 1,000 lines. It's an average growth, and with increases of data, 512,000 lines, and the growth of mistakes, the rate of mistakes is growing. If you have several millions of code lines, the problem is even more expressed. You can have many more mistakes, and the team has maybe not aware of it. Somehow the code may be functioning, and very often people who like our products, they say, why do we need your instrument? Because we have a project, it's 15 years old, it's working fine. Yes, we do have some errors, but they're not critical. We answer, what shall we do with the new code? Because you are supposedly writing a new code, and you're probably making mistakes in it. You're spending money to debug your code. It makes sense with the old code, you can work more like slow-paced, but the new code, you're spending money on it. And basically, this is like the whole history which I'm sharing about today. It's about the new code, freshly written code, but you have to take into account these stats. Next, would be a couple of words about a very old approach which is working. It's a code review. With the code review previously, maybe 5 or 10 years ago, you could even try to look for errors in your programs and try to fix them. But now it's working less and less. And when a person is given a code, if it's a legacy code, it's an older code, please look, find some errors in it. Probably it will be just a waste of time, or it may take indeed a lot of time. And also, usually, you have to use the best professionals for the code review. It's considered to be more efficient, which is more costly because you are using the time of the highly skilled personnel. So basically, as an example, just imagine that you are a qualified programmer and you get this code for your code review. This code contains a mistake. You can even try to look for this error in a matter of several seconds. It's a manual project. It's a source code on a C sharp. It's simply just an illustration about the code review. It's very difficult to analyze this big of the code because you cannot find the wrong line. If you do it around the clock, of course, your efficiency level will be less and less. This is the mistake, the error. I'm going to close it up, and here the programmer did a misprint. He or she just copy-pasted in this information, and it doesn't matter what condition you do, use system colors, what will be the value of the change. This is the piece of the code. It's the same value will be assigned. Maybe this mistake may not be that critical, you know, okay, it'll be the same color assigned, for example. But as a matter of fact, it's a very indicative example. This kind of mistake could result in more critical or even fatal error and problems. And the statistical analyzer, these kind of tools I'm going to speak about, they enable very quickly identify these kind of errors. But there is also a warning which says that with this color, which may be assigned twice. Yeah, speaking about the programmers, very highly skilled and qualified, unfortunately, they may not be aware of the full picture. People cannot know it all. Some people try to improve their code just by looking, browsing it. Again, it's a specialized instrument which is being developed by a team by many years. Any instrument, for that matter, will still be head and shoulders above the most skilled human coder. We cannot cancel the human error and human factor. This underwater part of the iceberg I'm going to speak about, of how can we catch it, how can we identify it, what's it's underwater, and how can we deal with it and counteract with it. A couple of words about the statistical analysis of the code, what it's all about. I know that you may be aware of it, but just again to give you a refresher. Here we have quite a humorous picture. It's a cartoon, but as a matter of fact, we may have some real problems with the wrong code, which sometimes even result in human fatalities. It's a code written on C++, and this is quite a classic error here. And we can see that this condition is being verified. And instead of double checking, instead of 2, they've written equals 1. C++ enables you to do that, and as a result, instead of double checking, you can always just assign the true, and the condition is always like right or true. And the robot is going to kill people whatever happens. And this is also like kind of in a way of joking, but it's also illustrates of why we need a statistical analysis. We are looking for quite a simple things, I would say, but actually they're not that simple. And we're going to go through the statistical analysis technologies, what's inside of it, what works, what does not work, and after that we will be able to understand of how these technologies are used, like, and what's the code security is playing its role in it.
amounts of data. And the negative part, the con, is that there's a lot of noise, and the statistical analyzers would give some percentage of false positives, and when the analyzer will say there is an error there and it's not there. So we split it for the most critical, high probability of criticality, medium, minimal, but definitely is noise. All the analyzers have it, and it can depend. And good analyzers would minimize that noise so that the programmer doesn't have to go through tens of thousands of messages that are false or cannot be understood. But anyways, the developer makes the decision, and he understands the code he has written. The analyzer is just showing those places to him. So those are the main issues here. And regarding the technology, we often hear, uh, for our analyzer at least, uh, they say you probably just have regular expressions and inside, and it's very works very simply. Why don't you let us add new rules because it's just adding another regular expression? We usually answer that no, it doesn't work this way. Those technologies don't work as well as we would want. And using just simple regular expressions, you just can find very simple constructs and there are a couple of examples where this doesn't work, like a plus b equals b plus a. These things people understand, and the program, the logic of a program will show that the same expression are processed. But you, to process it using the string matching, using regular expressions, doesn't work. And there are even more complicated situations. Those things don't work there. There are analyzers that solve those issues, and there are positive traits here, and regex-based analyzers. You can just put some source code through them, and they will try to parse it. But for full-blown analysis, it is not enough. It is important that the project is compilable because the compiling information gives you a lot of data. And if the analyzer is able to gather all that data, that gives you the opportunity to make deep analysis and understand what's going on with inside the variables using arrays and other functions, which makes the analysis more uh, functional. Here are the main statistical functions used. We will look into them in more detail. All the technologies are quite complicated, but there's no magic here. So, first of all, pattern-based analysis, comparing with a pattern. And the analyzer looks through your code and finds some situations that the analyzer knows. And here we have suspicious uh, situation when, for example, in the string array there is no comma, and it's very suspicious. And C++ allows it, and C++ will just concatenate those strings, but the chances of the programmer really wishing this to happen is quite low. The analyzer is not very sure, but he says, "Dear developer, please have a look." And yeah, it's true. The comma is missing, and this is an example of a pattern matching um, in search for suspicious situations and behaviors. And we find interesting errors. This one is a real error from Linux code. We had an article quite a while ago about this. And the analyzer found it. And this is one example of pattern matching. Going further, typing inference gives us a chance to understand what's happening inside the code. And this is in part already a dynamical analysis. It was present in statistical analyzers and gives you helps you to really deepen the analysis. We see a template of the structure here. An array is initialized, and there is a function that where we try to fill with zeros the area of memory that is inside there. The mistake is intentional here. Size of t is multiplied by 10, even though it should be multiplied by n. Uh, it was intentional here, and the analyzer understands that with the scaling of this template, something will go wrong because you have announced an array of 5 elements, and you will put zeros into much bigger, much more. Yes, this is. And this example shows that the analyzer was understanding the types, and it looked at what X is and understood how it's instantiated, and understood it will be an issue because the area, memory area filled with zeros will be much bigger. So here's one of the examples of the technologies used as part of the statistical analysis. Moving further, symbolic execution. It's easier to analyze and understand, and an analyzer is just solving a simple equation. We have a and b here. We don't know what x means here. It can have any value, but we can think that conclude that in such a situation, if we try to use a and b variables as the index of array by deducting a from b, we will be addressing the element that is outside the boundaries of the array. And array overrun is quite pretty much guaranteed. So the analyzer will be able to find those situations and make this conclusion. So some interesting examples regarding the data flow analysis. What is it? It's when inside some method, the analyzer for each and every variable saves its saves its state. It understands how it can change if it's new integer, for example, a number, whether it's a null or not. And based on the information about the values, and it's always the scope of values, the analyzer knows and can make a conclusion that something is going wrong. This is a real Chromium example, and we actually used to demo it as part of our stand and our booth on the exhibitions. And we have a function here checking the date validity, and it works incorrectly. It's called validate date time, and you need to pay attention to time month variable. Look what's happening here. A static array is announced which has a number of days in each and every month. And as the array is addressed starting from zero, then the first zero doesn't make any sense. So the analyzer looks for time month variable and understand it's limited by 1 to 12. There's some more checks, but coming to the second if, the analyzer knows that time month can be from 1 to 12. Then time month is limited uh, by being equal to 0. Uh, and here, look, it's compared to any value. Here it will be 2. And we see that 2 is less or equal than 28 plus 1. And the analyzer says, now this if is definitely true always. And if we look at the second if, which has the same error, time month is limited by being from 1 to 12. And of course, we see that any value from 1 to 12 is less or equal to any of those values. And this is always true again. So this is time of, instead of time month, it should be time day, of course, because we are comparing days with days. But the programmer has made a misprint, typo, and it doesn't look uh, very special here. So if it wasn't highlighted in red, it doesn't draw the eye. So here's how you can analyze the data flow and use it to find errors. And it's a real mistake in a Chromium project. Finally, uh, quite a simple technology, but it's very useful. It's when we know how our method should work. Method annotation. Uh, Imagine you have a library method and we know how to use it, like equals, for example, here. And of course, making equals function compared to variables that are exactly the same makes no sense. How does the analyzer work? It knows that equals should not receive the same arguments. And if it catches such a situation, then it says we have an issue here. Uh, we have already run through thousands of methods and libraries, and this work continues, but it really works. So if you have described the method once, for example, saying we should always have the return from the method, or and for example it was never used, then it works. And again, to reiterate on the thought I've started with, there's no magic. Uh, it's not very simple, but no rocket science. And we're going to next part asking what is SAST. SAST is statistical code analysis, and a couple of words about vulnerabilities. There's huge interest to vulnerabilities, I would say, a jump in interest. And if you have a look at the graph of the amount of the vulnerabilities found, we saw 5.5 thousand plus cases in 2008, like well documented that you could use if they were not fixed. And look at 2018. It's more than 3 times this amount, so it's huge growth. Probably it's not connected with the fact that there's more mistakes and vulnerabilities. I think it's because there's more interest, and usually it's community work or enthusiasts working, looking for mistakes, vulnerabilities in the code. There are special sites, special programs to do it, and we have now sites that allow you to describe those vulnerabilities and find them. And this growth is has a lot to do with the interest, and we see that there's more and more vulnerabilities, and the statistics for this year should, I think, even be higher. Here's the link down there where I took it, but I think you can also find it in other sources. So, what is SAST? It's classic statistical analysis, but it's just targeted at finding potential vulnerabilities. Why do we say potential here? Because the real vulnerability will not be findable using statistical analysis. Real vulnerability is when some researcher has found some gap in the code and he used it. And the statistical analysis can just say that this place in the code can potentially be used or potentially be dangerous. So if something goes wrong, then the software will not work as designed or as the programmer expected. And the SAST story is very important here because by uh, removing the vulnerability, you, in many cases, remove the real vulnerability. And you don't need to care that the code you have created can be dangerous or can be exploited. And the main thing here is that the statistical analysis correlates well with those standards and technologies. I've mentioned a couple of them here. There's definitely more. There are standards where those vulnerabilities are mentioned or listed, and the patterns that the statistical analyzer will show you those issues and say like, hey friend, you have some security vulnerabilities, security issues here. And the correlation between traditional errors and vulnerabilities can be quite high, and it's more than 60% based on some research. A picture for your information, like it's very fancy now. DevSecOps, SaaS technology, and is part of dev part of DevSecOps as part of the development, and the programmer is using statistical analyzers or SAST instruments on his or her machine. It's the most well appreciated way because the programmer knows the code and he has written it himself, and of course he can just run it between the commits and look at them and fix them. So it's all done on the developer's machine, and it's part of DevSecOps. And speaking about how those vulnerabilities are found using statistical analysis, you can use two ways. You can be looking for old code, but there it's more like antivirus, how antivirus works. Imagine you have libraries, well-known libraries of well-known versions, and the code is not changing there, and there will be vulnerabilities found there. Probably you will have less false positives, but the issue is the code is old. What do you do with the new code? So first thing comes to mind are new technologies and new language constructs that you cannot find when you're just searching the old code. So the second way, when you analyze the source code, is more favorable, and you try to remove vulnerabilities or prevent vulnerabilities there during code creation. It still works for the old code, but the amount of work you have to do is much bigger. So our analyzer works the using this second way. We use the second way. The recommendation, as I said, is that the developer uses the technology himself. Of course, you can use it on release server by QA during testing, but this all increases the spend significantly. And if you miss the error and it went to the deployment server, then someone needs to find it and send those happy mails. He will spend some time, and the programmer will uh, receive the feedback, and some tests will be done. So of course it's harder, and of course if you missed the error and it went to release, then the losses are much higher. So some research here stating that it's quite simple, quite understandable. So to minimize risks, you need, of course, to find those issues earlier, and the reputational losses can be high, not only the financial ones. And um, as I said, there are two well-known technologies for potential vulnerabilities. So CWE is common weakness and enumeration, and CV are real vulnerabilities. So look at this funnel of errors. They're very different. Some part of those errors, for example, it's usually 60% or more, are uh, common weaknesses. They are constructs in the code that are suspicious in terms of security. And under some circumstances, this code can work incorrectly, not as the programmer expected. And based on that small number of potential vulnerabilities, uh, we can have some part of them becoming the real vulnerabilities. It's when the community has worked or research has shown, and it's already mentioned and documented as something found in your code. We know what this vulnerability is, how you can exploit it, where does it fix it, whether it was not fixed. This is very thin line of difference that you need to understand. So the methods we are talking about are looking for CWEs. Um, so CWE is there's a lot of rules, and they correlate well with the mistakes that are found by the statistical analysis. And when we were implementing those CWE into analyzer from more than 800 of rules, we were already covering a lot. And those rules actually cover quite a significant amount of potential vulnerabilities, like going out of the array boundaries, crosslinks, etc., etc. So yeah, you can walk through that list and get some examples and try to understand what it can lead to, whether it will be vulnerability or not. But it's best to remove it. It will not be your issue any longer after that. So some examples, like compiler can remove some code or optimize something. Uh, Unchecked data usage, non-initialized variables usage, etc., etc. So a MySQL example, quite a well-known one. It's a real error. We see here the analyzer saying we have W507, and the compiler can optimize it. Yes, the compiler has the task to. It really has the task of making your code optimal. So in the release, it will remove that map set because this Win32 op is not used. But the programmer uses it. he wants to fill it with zeros, but a good compiler knows doesn't know a lot about what the programmer wants, and the compiler would say, "Hey, yeah, this is not really needed," and it will be right. So this construct will not work in the way that the developer has designed it. This line will not uh, make it into the binary that is finally deployed, and the memory will not be cleaned. So the actor can actually use it. And so the data is still in the memory. And also this code has another issue. Look, different type of diagnostics 579 um, says that the internal variable of Win32op is used, and it has the same structure and size of. Even if that memset would be used, then everything would go wrong, because instead of the size of the structure, it sends the size of the pointer, and of course the size of the pointer will be smaller, and some part of that structure will not be filled by zeros. So this line actually has two errors. Classical analyzers look for those things, and whether you should be fixing those bugs or not is your decision, and yeah, it's on you to decide. Next example is Amazon on Web Services based on Sharp. It's in the first block of if someone forgot to put the return, and based on the program logic, the same variable is assigned the value, and it's looks stupid. So the analyzer warns us about this. This is potentially a vulnerability because it has the number 563 is described, and whether we will use it or not, we don't know, but the issue is here. Another example from Amazon Web Services is endless recursion. The analyzer says that this code will probably not execute very well. It's a classical situation with the on failure field announcement, and the name of the function and the property different by just one letter. And as the programmer made a mistake by typing a capital O instead of small o, then the recursion occurs. Well, how did this code work? Um, Looks like it didn't work. I looked at it. It was not used, but a good analyzer would check an unused code also, and because if this is uncommented and goes into the real execution code, yeah, it's CW uncontrolled recursion error. So here we talk about real vulnerabilities, things that were documented. Same meter org association documents them, and here are the real ones. Look, first example from MySQL. This one was found in 2012. It's CV vulnerability 2122. It's a real one. It was removed. And what the guys did here, they're comparing using memcmp two arrays, and the result they are putting into a char. So they have created their own type, my bool. So memcp would return its result as an int. The int will be concatenated to a char, and the all the higher bits would be lost. And the check scrambler uh, will be working when you just have a lot of BS as an input. In one case out of 128, it said doc. So it's a long and well-defined description. So statistical analyzer can find this thing. If you compare int with char, then usually this issue will arise. And we see that the statistical analyzer would actually throw an exception here and point this code out to you. How did we find it? We put this code into the analyzer, and so if developers were using statistical analysis, then they will be definitely ready to.
They're using the methods of print. They're writing. They're trying to print out some debugging information in this proof which they're selling. It's basically the specificators like in print. It's uh, percentage %f, percentage %t. Prints like size log is putting the data on the stack, and stack is collecting the data. So if you have the supply the list of incorrect specificators there, it can extract data which has no relation to this case whatsoever. You can write the line of specificators and go all the way up to a different area of memory and to see what's in the memory. So it's a real vulnerability which has been described, and because they have used here specificator not in overt version, you could supply your own specificator and then dig into the memory of the processor in the real time and to extract some information which is not up to your level. It's a real vulnerability identified in 2013 in the NAS project. Next case, quite interesting in iOS, back in 2014 had been identified. You can see the programmer had written 2 times goto. It's a nonsense even to use goto, but they're using goto. But it's been double printed here. And it makes sense that the logic of the program has been broken here. Had they used any analyzer, and it could give them empty warning. In addition to logic violation, there also could be the unachievable code and strange formatting go to 2 times. And of course, the last if had not been worked out. They put some signatures, some key, and it's been very bad. And all these things have been fixed by now, but as an illustration, all of this has been documented. Now, quickly, I'm going to go over different standards, not the wrong words, but standards. MISRA is another very good standard which has been used in automotive industry. It's also about a very safe development, but it's about development per se. This is the way you should be writing your code in such a way that you could minimize number of mistakes and vulnerabilities. Basically, this MISRA is really, really popular by embedded systems manufacturers. It's for the C++, and a lot of rules comes with it, and the rules are like never use goto, for example. It's one of the rules. And other rules is like there should be one exit from the function, type of the cases and different things. So the standard is quite complex in the sense that if you're using this standard in a legacy project, there'll be a lot of ticks off. But if you follow all the conditions in this MISRA, there are about 143 to 128. You may believe that your code is quite safe. Now, a couple of words about this MISRA. Another standard, CERT, which is quite well known, and it's for C, C++, Java, Perl languages. It's very, very common to the CV. The idea is the same, certain patterns of mistakes, which will enable you to find some structures at the entrance to fix them, not fix, but minimize the number of potential vulnerabilities. And the rules are just like that, very much to what we've been saying before. It's about optimization, that the compilator can optimize everything without your knowledge. So these kind of things have to be controlled in your code. Basically, that's it about technologies, about the standards, and a couple more words as I'm finishing up of how we recommend to use your SAST, statistical analysis, and all the technologies. It is true for all the static analyzers, not only about our analyzer. And you have to identify your own tool which will be fit in your project because analyzer has to be chosen. There are no perfect analyzers. Some analyzers, they're looking for different smells in the code, and others, they're looking for vulnerabilities in the code, potential ones and real ones, analyzing legacy codes. There's certain analyzers which are working with the binary code. We've been working with source code. While other analyzers analyze in binary code, it has certain advantages and disadvantages. So once you've chosen your analyzer, you have to set it up. The right setup will help you to minimize numbers of false positives, like by one order or two order of magnitude. Sometimes people take our own analyzer and take their projects with the 5 million of lines of code. They say there are hundred thousands of checks. What shall we do with that? They're given recommendations. They do the tune up. Instead of 100,000, they have 1,000 of warnings. So you can work with it. But you just have to work with the new warnings. It's a main idea of the statistical analysis that um, when we write articles, we check the projects, we get 1,000 articles and 1,000 errors and write articles. But in real life, you take analyzer, you find 10,000 errors, which you will definitely have, and you put them off. You you put them aside, so to speak. A good analyzer enables you to put them away for a while and start working with the new ones. The most interesting thing is a new code which your team is writing at the moment. You can always go back to a legacy code and you can correct it any time because your project has been developing for many years and your old code is working. Yes, you can make it perfect if you'll find time for this. So you embed analyzer on Kanti's integration to the collection service because you have to have some final point if your coders have found some mistakes at the assembly server during the night assemblies. Let the analyzer again to go through your code. But the most optimal thing is to use SAST at your workplaces when a developer has written a code, made some mistakes, double-checked it, and corrected it themselves. The company has sustains no losses because there were no losses, and the program is feeling great because if if their flows will go to the level of continuous integration, then managers get all these notifications and messages that Mr. Such and Such has made mistakes, which is a redundancy works. And a couple more slides about losses. Whenever we have vulnerability, it's a certain algorithm or sequence of what may be happening, and this is how it is happening. We have a vulnerability, we have different losses, corrections, updates, but if in this chain you embed SAST or any other instruments for minimizing mistakes and early detection, this is what it looks like. Yes, you have an error, there are no programs without any errors, but having fixed it, you cut off all the possible problems, including the real vulnerabilities and potential ones. And it does work, and we have to take advantage of that. And some of the takeaways, one of the most obvious one, you have to use all kind of technologies available, even for review. I've been speaking about the code review in the very beginning. It may not be the best technologies, but it has some advantages. You can train your juniors, for example, or or double check certain standards in your company, and simply to look for errors. To look for any errors in the code using the code review is not efficient. If you can afford, you have to go ahead and use all the instruments, static and dynamic analyzers, which is a very classy and good thing. But you should not limit yourself only to these things. Use everything you can afford. It's simply one of the barriers on the way to errors. And a company which today is trying to make money on it, they have to understand it and they have to use it. Otherwise, they will not be competitive, unfortunately. In the modern realities, this is the way it is. Thank you for your attention.